Okay, so in this case, because we have a squared plus x squared, we're going to let x equal to 4 tangent theta. And then we find dx, which is going to be 4 secant squared theta, d theta. And then we are going to figure out what 16 plus x squared changes to. So we're going to make this substitution. So this is equal to 16 plus 16 tangent squared theta squared. And this is equal to 16 squared times 1 plus tangent squared theta. And 16 squared, well, that's 256. And then 1 plus, forgot the squared here. 1 plus tangent squared, that's secant squared. So this is going to be secant to the 4th. So this right here is secant squared, and then you square that, so you get secant to the 4th. So this right here is going to be secant to the 4th theta. And then the dx, of course, is going to be substituted by that. So then what I get is this is equal to the integral. And I'm going to leave the limits of integration out for now, and I'll just put them in the end. But I'm going to get dx, which is 4 secant squared theta d theta over secant to the 4th, 200. Let me change the color. 256 secant to the 4th theta. I actually forgot to put the 256 here because it's down here. Okay, and then we do a little simplification here. 4 and 256, that's going to give me 1 over 64. Not 164. 1 over 64. And then I have the integral of these two. This is going to be 1 over secant squared, but 1 over secant, that's just cosine. So this is cosine squared theta, d theta. Okay, then I use the trig identity for this, which is 1/2 1 plus cosine of 2 theta. So this is going to be 1 over 128, 1 plus cosine of 2 theta, d theta. Okay, and so this is equal to 1 over 128, and then I have theta, and then the antiderivative of cosine of 2 theta is going to be plus sine of 2 theta over 2. Okay. Now I need to switch back to the original variable so that I can plug in the limits of integration. So let me do that over here. So because what I have here is x over 4 is equal to tangent theta, then that means that theta is equal to inverse tangent of x over 4. So that's what that is. So I'm going to plug in inverse tangent of x over 4. Okay, so that was easy enough. But now for this one, I'm going to have to use the trig identity. So let me go back. So sine of 2 theta, I'm going to write that as 2 sine theta cosine theta instead. And so then the 2's are going to cancel, right? But this is the case where you have to do the triangle, okay, because we have our theta here. And so since we know that tangent of theta is x over 4, that means that I have x over 4 right here. And so then the hypotenuse is going to be x squared, square root of x squared plus 16. Okay. And so then this is equal to 1 over 128 inverse tangent of x over 4. And then plus, now this is going to be just sine of theta. So let me circle these. Sine of theta times cosine theta. So sine of theta is x over square root of x squared plus 16 times cosine theta, which is 4 over square root of x squared plus 16. Ooh. Okay. All right, and then I need to evaluate this. So let me erase everything else. So this is going to go from 0 to 1. Okay. So off I go to plug all this in. I have 1 over 128. And then I'm going to have inverse tangent of 1/4 plus, if I plug in 1 into here, this is going to be 4 over, and why don't we'll combine these two into just 1. This is just going to be x squared plus 16. So this is just going to be 4 over 17. Let me erase this. Okay. And then, okay, and then I have minus. Then I'm going to plug in 0 here. So this is inverse tangent of 0, and then plus 0. So this whole thing, both of these are going to be 0. And so I can just do this one right here.